Hello everyone. Today we are going to discuss Codeforces Round 888 Div 3, and we are going to discuss problem A, B, C, D and E of this round. So the first problem A is escalator conversations. So in this problem we are basically given four variables nmkh and an array which is of size n and contains some numbers which are represented by h1 h2 up to hn. There are basically some number of peoples. It is represented by this n. M is the total number of steps in the escalator, and k is the height of each step in the escalator, and h is the height of Vlad's. So we are basically given, if let's say an individual among these n people have a height difference of x with respect to Vlad's height, that is h centimeter, is such that the difference between the height of the steps they are standing on is same. So this problem actually becomes something like, since we are given total number of steps as well, so at max what can happen is Vlad can send on the first or the last step, and the other person can step on accordingly. If Vlad is on the first step, then the person can stand on the last step, and otherwise the person can stand on the first step if Vlad is on the last step. So the maximum height difference they can have is basically k times bracket m minus 1. That's the maximum height difference Vlad can have with anyone, and if it is more than that, then we will not count that person. And otherwise also there is a thing that on a single step, I mean on the one step, there can only be one person. So if let's say two people have same height, then we will also not calculate that person. So it actually means that this code looks something like, we will first of all input the variables given, then we will input the array, and we will simply iterate over this height of various n people. If they both have different height and this difference is divisible by k, which basically means we can like stand on two steps accordingly, which will be equal to their height difference, and the difference divided by k means how much stair they have to like stand apart. That will be calculated by this value, and if it is smaller than m, then only we will increase the answer. It basically means, if I explain again, the two person should not have the same height because they cannot stand on the same step. And second thing is, the both of these person cannot have like, they cannot have such a height difference which is not divisible by k, because then if they are standing on any of the step, their height difference will never ever be equal. So it should always be divisible by k, and it should be such that the stair difference or the steps difference, the steps they will be standing on, should be smaller than m, since we only have total of m steps in the escalator. So then only we will increase our answer, and initially answer is 0, and at the last we will print the answer as our actual answer. Now let's discuss problem B. So this problem is parity sort, and it basically said that we have some array A of length n, and the only operation we can do is we can swap two element ai and aj such that I is not equal to j, and ai and aj should have same parity. Means we can only swap two numbers if they are either both even or both odd. That's the only thing. So they ask us, can we sort the given array using any number of operation, like any number of times these given operation. So this basically means is, see, it has a simple observation. We can arrange the odd numbers in any order we want, in any order, because we don't have any constraint on the number of operation we have to do. So like number of same parity, like 7, 1, 3 and 2, we can arrange them in any order. Like we can take 7 on any of these three position, and accordingly we can like arrange them in any order. Same we can do with numbers with the other parity, means the even parity. Like we have just one even number over here, like 10, But otherwise, let's say had there been some more number of numbers, like even numbers in this array, then it would be possible to arrange them in any order as well. So that is the thing. So the observation is this only. Let's go opposite way. We will copy this array into another array and sort that array. And now we say that if the respective number, I mean, let's say if the array is something like 2, 1, 3 and 4, or let's say something like, okay, 2, 1, 3, 4, let's take this example. Sorted array would be something like 1, 2, 3 and 4. So 4 is at its position, 3 is at its position, but we have to somehow place 2 over here and we have to place 1 over here. But the original position, like at the original in the original array, we have an even number at this place. So we can never ever have an odd number at this place according to the given operation. So we basically have to check among the given array and the array which we will get after sorting, that for every position, like it is mandatory for every position, that the parity of both the numbers should be same. If it is different even for a single number, then we cannot sort it. Otherwise, if it is same for all the numbers at every position, then we can sort it. That's the only thing we have to do in this problem. Let me show you the code. So the code is simple. After taking the input, we have this flag as true, and we are iterating, and we are saying if ai percent 2, which basically means we are calculating the parity. If it is not equal to bi percent 2 for any position, we will simply do flag equal to false, and if flag is true, we will output yes, otherwise no. That's the only thing we have to do in this problem. Let's discuss problem C. Okay, so this problem C is tiles come back. This problem basically say that we have two variables n and k, and we have an array of size n as well, which basically contains different number. These different number basically means they are different color, or you can say they are of different type. Numbers in this array with 1, 1, 1 are of same type, with 2, 2, 2 they are of same type, and so on. So basically this array has different numbers with different colors, basically numbers with different color. For example, it is given over here, like one they have depicted it as red color, 2 as pink, and so on. So what this problem actually says is, first of all, it is also given that we will start from the first tile and we have to end at the last tile. So that is one observation. Basically they have mentioned it over here what they require. So firstly, it is given that we will start from the first tile and we have to end at the last tile only. Now they said we have to move in such a path, then we can skip any number of tiles we want, and we have to only move towards right. If let's say I am on the ith index, then I cannot go backward, I can only move forward, like at the right side, I cannot go on the left. So they ask us that we have to move towards the right, and we can like skip any number of steps, and we have to stop at the last index of the array, such that the total number of steps taken, basically total number of steps taken means wherever we have like landed over, like wherever we have like put our step, that basically means the total length of our journey or the path. So it should be divisible by this given k variable. Also they said that this path should be divisible by k, and this path must have block of size k each. That's what they mean. And every block must have same number of same type of tiles, which means if we are like starting from 1 and it is given, let's say k is 3, then we have to first of all go to 3 tiles of same type. Like for example, in this given example, let's say k is 3, then we are starting from the first tile as given in the problem, then we have to go to the second tile of the same type and to the third tile of the same type. Now after going to these 3 tiles, since k is 3, we are now free to move to any other type or any other color tile. So after going like after moving from 111, we are like free to go to, let's say, of this type 7 tile or type 5 tile or type 3 type accordingly, or we can even go to the same type of tile again if we want. Now they are asking us to only tell if there is a path, if there is such a path which follows all these given conditions. So basically we have to move in the array such that this total length or the total steps, number of steps, these number of steps, these are divisible by k. And now there would be some blocks of size k each. This is a block of size k, let's say this is also a block of size k, and another block of, there are, let's say, 4 blocks of size k in our path, k, and the numbers inside, like the tiles we have taken inside these k, these all should be same in an individual block of tile. Means if, let's say, there are k tiles, then all should be either 1 1 1 1 or 2 2 2 2 or whatever. They should be same in one tile. It could be possible that in the adjacent tile or adjacent block they could again be tiles of same type. Like if there are 1 1 1 over here, they can also be 1 1 1 over here. It doesn't affect anything. We just have to follow this property that in a given block they should always be tiles of the same color. So that's what they say. Now this problem basically reduces to, first of all, let me tell you, if let's say there is an answer, or let's divide this problem into two category, or basically two cases. One case is when the initial and the final, or the first and the last tile are of same color or have same number. Then we just simply have to find if there exist total k tiles of this type, either of this type, because they are both same. Then we will print yes if we have total k or greater equal to k tiles present. Otherwise, this is the simple case. The second case is when these are both different, like the first and the last are different kind of tiles. In that case, we have to go greedily. First of all, we have to find as soon as we can k tiles of this type, and let's say we have like found greedily as early as possible k tiles of this type, like at this index. Now we have to find after this particular index k tiles of this type. In the second case, if this condition is present and this condition is true, then we will print yes, otherwise we will print no. That is enough to check in this problem. So let us check the code. So I basically first of all took the inputs, and I have this special flag. I'll tell you why I have this sp thing, and I have initialized this equal to 1 when the first and the last character is same. Now I have this flag variable which I have initialized as true, and then I have this temporary variable which I have declared it at the very first moment. Then I am initializing it as k. Now I am having this while loop in which TP should be greater than 0 and ID should be smaller than n. ID is nothing but index, which we are starting from 0. It should be smaller than n. That's what this while loop has all the condition. And inside this while loop, I am having a simple if condition that if CID equals C0, which basically means I am first of all checking this thing. It will include the first case as well. I'll tell you how. So first of all, we are finding the k, k numbers or k tiles of this type. First of all, we are doing that. So in this while loop, we are doing the same thing. If CID equals C0, we are doing TP minus minus and ID plus plus. And as soon as TP becomes 0, or let's say ID becomes greater equal to n, we will break out of this loop. Now if TP is non-zero, which means id has exceeded the maximum length, in that case our answer doesn't exist, because we are not even able to find k tiles of this type. We have not reached this position yet, but we have failed to find this type of tiles, total k tiles of this type. So we will print no in this case. Otherwise, if tp equal 0, then this is the condition. If let's say sp equal 1, which means that c0 equal cn minus 1, which means we have found the k tiles. As I said, I printed yes in this case. Otherwise, if sp equal 0, which means first and the last element are not equal, then we have to repeat this process for the last tile again. Here we are doing for last tile, here we were doing for the first tile. Okay, and lastly, if tp is non-zero, in that case our answer would be no, otherwise it would be yes. So that was it for this problem. Now let's discuss problem D. So this problem B is prefix permutation sum. So basically this problem says we initially had some array of n elements, or rather a permutation of n elements. Permutation is an array which has numbers from 1 to n, and that occurs only one times in it, and they could be present in any order. That is the permutation. So we had some permutation initially, then we formed prefix sum from that permutation, and after that after forming this prefix sum, one element of that prefix sum is lost. Now you have prefix sum with one element lost, which basically means a prefix sum of size n minus 1. Now we have to tell, can we have a valid permutation for this prefix sum? That is the actual problem, and we have to output yes or no accordingly. If we have a valid permutation for this given prefix sum, then we will print yes, otherwise we will print no. So how basically I approach this problem is, so let's see. Since this is a prefix sum, there would be two cases. If let's say there are initially n elements, and that too a permutation from 1 to n and occurring only once, then the difference between two consecutive elements would always either result in an element itself, or at max what can happen is the difference between two consecutive numbers would be bigger than the greatest possible number in the permutation, that is n. So if that's the case, for example, in this array, these two consecutive numbers have a difference of 7, and which is greater than 5. So in this case, it basically means this is the sum of, if let's say it is a prefix sum of a valid permutation, then this must be sum of two numbers, like two numbers from the permutation. So what we will do is, we will keep them aside for some time, and we will continue for the other like the difference of other consecutive numbers. So that is one case, if the difference of two consecutive numbers is greater than the original biggest number possible. And the second case could be the difference, the difference of two consecutive number is occurring two times. That is the thing. So in that case, it again means that one difference which is occurring the other time, it must be the sum of some other two number which are obviously smaller than this sum, and those two numbers are forming it. That's why it is occurring again. For example, let's say 3 as a number is occurring, and let's say 1 and 2, the sum of 1 and 2 is also 3. So it is occurring. So one of them is missing somehow from the prefix sum. That's why we are having this 3 as a prefix sum two times, like the difference between two consecutive values. So these two are the cases which we have to consider. So let's directly jump to the solution, what I basically did. So I first of all took the input, and first thing to notice is I have this prefix sum array, and first of all I pushed 0, then I pushed all the remaining n minus 1 elements which are given in the problem, the prefix sum basically. So why basically I did this is, I will consider the first element given in the problem, means this first element as the sum of two consecutive numbers as well. Like I'm assuming there's zero number initially, which basically means nothing. It means this first element either must be a single element, or maybe element from the, like the prefix sum, an element from the prefix sum from the start is missing. In that case, it is sum of two elements. That's why I am considering this as well. So that's why I basically pushed first of all 0 in this prefix array, then I pushed the remaining elements given in the problem. Now I have this set, and in the ST set, in this ST set, we basically inserted the permutation from 1 to n, basically all the numbers from 1 to n, I mean. Now we are iterating from 1, remember, the second element up till the last element. And what basically we are doing is, since our prefix array is now of size n again, because we explicitly pushed 0 in it, now we are doing that if st, which means this set which contains the permutation, if it contains the difference of pr of I minus pr of I minus 1, basically the difference of the two consecutive which we are currently on, like the current one and the previous one, because we are starting from second element, that's why we are taking the previous difference from the previous and not the ahead one. So if st contains this thing, then we will simply remove it, and it means if it contains it, it must be smaller equal to n. So if it contains it, then there is no issue, and we will simply erase it from here. Otherwise, if it doesn't contain this difference thing, then it can only mean either it is bigger than n. That's why we checked if the difference is bigger than n. Then I basically inserted it in big set, which I mentioned over here. And otherwise, if this is the other case, means it is not bigger, like greater than n, it means it is occurring second time. Because why it is not present here? Because it must have been removed in an earlier iteration. So in that case, I am inserting it in the smaller one. Now I am simply having this thing. If let's say the set size is greater than 2, which means set has greater than 2 elements. If this is the case, if set contains 3 or more elements, or the sum of big and small, basically both of these have size greater than 1, which means 2, then we will print no. So I hope you must have understood why it should be, when if it is greater than 2, why it is no. Let me explain you in this case why, if the sum of these two is greater than 1, then why it is why the answer is no in that case. So the thing is, either you can have the difference of two consecutive numbers greater than n. In that case, one thing is, since we have only one element missing, which means let's say if there are ABC 3 elements consecutive, and we took some these ABC are basically prefix sum, and only B is missing, let's say, then the effect of this missing element would be on the two elements A and C only, and it will not affect any third element. So that's why for this set size, it should be, if it is greater than 2, it means there is some other issue, and if it is greater than 2, then the answer would be no. Same goes for this. Then if big dot size plus small dot size is greater than 1, then it is no, because either it could be that the difference of two consecutive element is greater than 1, or it could be that two elements are occurring at the same time. I mean, one is element and other one is sum of any other two element. If both of them are occurring simultaneously, it means there is some other issue. In that case, we will print no. Otherwise, it means we have this set size equal to, and we had this else section again. It basically means when set size is 1, it means we are all clean and we can print yes. Now this is the main thing in the main logic we will consider. So when set size is equal to 2, we will basically take the sum inside the elements, means the two element present in the set, we will take their sum, and if this sum is equal to any of that, see, because we have a check over here, it means either big dot size has the element, or either SML dot size or the small set has the element. That's why we have this condition in which either SM equal BG dot begin, or sm equal sml dot begin. If any of this condition is true, we will print yes, otherwise we will print no. So what basically this condition means is, the element we got, since the BG set, the big set will have the difference of two consecutive element which is greater than n. Okay, and the smaller one, the small set, will have the difference of two element which is not greater than n, which is smaller equal to n, but it has occurred the second time. We haven't we were unable to find it in the ST set. So it means it is a sum but of two smaller elements. So we basically have to check that if the remaining elements in the set, since we are like finding the elements in the set, we are removing it. So at the last, since we are going from the second element to the last last element, so we will at max remove n minus 1 element, and it could be n minus 2 in the case when there is a repetitive element, like the repetition occurs. So that's the case which will fall in this bracket. So if the remaining element in the set, their sum, if it is equal to bg dot begin or it is equal to sml dot begin, then the answer would be yes, otherwise it would be no. I hope you got the problem. Now let's discuss the problem E. So this is an observational problem, and it basically said that there is an alchemist Nastya, and she loves mixing potion. So basically, let's come to the point. It basically have two variables n and k. N means the total number of potion types we can like have at max, and k means the number of potion type Nastya already has. Okay, now these k potions basically she has in abundance, like they are in infinite number. Basically she can make any other potion if she can, like if it is possible, then she can make out of these k potions she already have. And the second line basically contains the cost of each potion. If she, let's say, want to buy, obviously she won't buy the potions she already have. If she have to, she will buy any potion in this much of price. So that's the cost of buying any ayat potion. Again, in the third line, we are given k distinct integer, which basically means the potions Nastya have in unlimited supply, as mentioned here. Now the following line, like after the third line, there are n lines in which first of all we have this some integer mi for every ith line. After that, it means the number of potion required to mix a potion. Like it basically means after the third line, which means the line after these k potions are mentioned. After that, every ith line indicates that to make the ith potion we require mi number of potion, and after mi there are basically mi distinct integers, which means to make the ith potion we require these e1, e2 up to emi potions. We have to mix them. That's what is indicated in the problem for every I potion. And if the value of mi is 0, that means either she have that potion already, and if she doesn't have that potion, it means that potion cannot be made up, or that potion cannot be mixed up from any existing potion, and she only have to buy it with the respective price that potion has. So now they are asking us to tell the minimum price of each potion we can make. Either we have it, or we have to like buy it, or we have to make it. By whatever process, we have to tell the minimum amount in which we can make every potion. So that's the problem basically. So what I basically observed in this problem is, first observation is which is a bit catchy, that it could be possible that we can buy one potion for some price, but it could also be possible that we can first make this potion out of some other potions, and after that let's say any third potion requires this made up intermediate potion, and we will make that third potion using this, and this chain could link up very long. So a standard way of like doing, since I initially got this idea of doing a simple iteration, like a greedy thing over it, but it will not work because there could be a long chain, like a long dependency thing on of one portion over other. So that's why this idea has been dropped down to do a greedy thing. So this dependency thing of portions clicked an idea, and what that idea was, basically every portion, like either if Nastya has this portion already, in that case she doesn't have to do anything, she since she already have, and in that case the cost will be 0. Otherwise, if she cannot make this portion out using any other portion, then she will simply buy it for CI coins. Let's say it is ith portion, then she can buy it for CI coins. And otherwise, if these two conditions are not the case, like if a portion is not even like present in the Nastya's bucket, or Nastya means Nastya doesn't have that portion, then she can either buy it or she can either make it. So whatever is cheaper, so she will do that. So basically it means the portions have dependency. So it basically clicked the idea of topological sort. So let me first explain before I jump to the whiteboard. Let me first explain the test case. Here we are given n and k, then we have the cost of every portion, like 0 1 2 3 4, every portion, all these 5 portion, and then we have k. Since k is 1, so we have this portion, means Nastya has third portion in infinite supply, and after that there are n lines, means there are 5 lines. In that first element, means this ith, means the 0th portion or the first portion will be made using 3 portions, that are second, 4th and 5th, and using 0 index. The portion, the 1th portion, we cannot get it from any mixture. Same for the 2th portion, and for 3th portion we require 2 portion, 3 and 5, and the 4th portion, it is also same, we can only either buy it or it is already available. We cannot make it using any other portion. So that's how the test case goes. Now let me tell you what I was saying about topological sort. So I mean, there are, let's say, some portions, let's say 0 and 1 portion. Let's say portion 0 is infinitely available, so it has a cost 0, and this portion 1 is not infinitely available, but it cannot be made using other portions, so it will be made using 18 coins. Now there could be some other portions which could have like dependency, like this 2th portion could have a dependency from 0, then there could be a 3th portion which have a dependency on the portion 2, which means this third portion can be made using the second portion and the first portion. Okay, means the 2th portion and the 1th portion. And there could be 4th portion which could be made using 0th portion, let's say second portion, and let's say 1th portion. So this dependency could go on and on. So that's why I thought upon the case of the topological sort. So we can basically do a topological sort on these dependency, and we will find, first of all, the portions we can make with less dependency. Like first of all, we will find the minimal cost of these two, then we will find the minimal cost of this one, and then we will find the other, let's say there is a third portion with multiple dependency, let's say, okay, this kind of dependency, then we will find the cost of this one, and so on. That's what I thought upon for this problem. Now what happens is, what I did basically is, now we have to like discuss the code. What I basically did in this problem is, firstly, this is a standard toposort function, we are not going to discuss it. It basically has an adjacency list, and we have passed an array which will contain our toposort. Then we have passed a flag variable which will basically tell us if a toposort exists or not, means if there is a cycle or not. And we have this basically the size of the array. So now we have this function, it will turn us a toposort. So what I did in this code is we took the input, and in the input we have changed some things. We have this answer array which will basically contains the answer, like the final answer of the minimum coins required to make all the portions. And initially we have initialized equal to the coins, because that's the minimum value we can have at any time. And in this array where we are like inputting the portions which Nastya already have, we then are putting the value for that particular portion equal to 0. Now after taking the input, basically the dependency, we have two adjacency list. One is the direct dependency, means how we can like make a portion, like a portion is made up of what other portions. Like for example, this portion 3 is made out of 2, 4 and 5. So it means 2 will have a directed edge towards 3, 4 will have a directed edge towards 3, and 5 will have a directed edge towards 3. So that's what I did in this section. After like taking the input, what we are doing is we have this ADJ adjacency list which has directed edges from the dependency towards the portion it will make. And there is another adjacency list which I am calling SC. It has the direct, like the right edges, right directed edges, which means it is directing from 3 towards 2, 3 towards 4 and 3 towards 5. That's what SC contains. I will explain why I have this. Now I have basically first of all have this flag thing true, and I am calling this toposort function, and then I am saying if flag is true, means there exists a toposort. In that case we will do something which I'll explain in a moment. Otherwise we will simply put like print the answer, which is nothing other than the initial cost array, and updated with the unlimited portion equal to 0, the value of them. Otherwise if there exists a toposort, what I did is I have this for loop which I iterated over the toposort, and then for every portion that is like that has the least dependency, since it is a toposort, we are going according to that. Then we have this temporary sum, basically, which means how much cost it will take to make this portion using other portions mentioned. So that's why we have this SC adjacency list. That's why we iterated over it and added the value of, since we have already done a toposort, it means portions which it is made up of already have been calculated the minimal possible cost. So that's why we are doing a TP sum plus equal to answer j. And now if this SCI dot size has a positive value, like a non-zero value, which means we can like make it using some portions. In that case we will simply do answer I equal to min of TP Sm answer I, means the original array which is from the C array, like the original cost array, and minimum of if we can make it from using like the portions mentioned in the problem. So that's what we did, and simply printed the answer later on. So these are the explanation for these 5 problems. I hope you like the video. If you have any query or have any problem, please feel free to comment it down, and please subscribe to the channel as well. Thank you.